Our topic is fraction word problems, which is drawn from section 1.4 of the book Passing the Minnesota MCA-II Grad Component Mathematics Test, Revised Edition, published by the American Book Company in 2010. So we have a fraction word problem given to us, and I'll read it. Sarah buys candy during the summer. During the first week of summer, she buys 1 1/3 pounds. During the second, she buys 3/4 of a pound. And during the third, she buys 4/5 of a pound. How many pounds did she buy during the first 3 weeks of summer? Well, being a word problem, this is where the real world and mathematics meet. We take a look at our overall impression of what's going on in this problem, and well, my first impression is that that is a lot of candy. Leaving that aside, we'll make no judgments on that, but we'll solve the problem for its mathematics. What is the problem asking? It is asking how many pounds did Sarah buy during the first 3 weeks of summer? Okay, so I'm looking for the total number of pounds. I might write that as the sum of how many pounds she bought during the first week, which is 1 1/3, plus how many pounds she bought during the second week, which is 3/4, plus how many pounds she bought during the third week, which is 4/5. All right. First thing I notice is that this first term is a mixed fraction, a mixed number, which has an integer part, 1, and a fractional part, 1/3. I would like to convert that mixed number to a fraction. So 1 1/3 is really, I can express 1 in terms of thirds as 3/3. So any number divided by itself is 1. And I still have this 1/3 here, so plus 1/3. And the reason I did that is because that's what I need to do to add fractions together. I need to have the same number in the denominator because I'm now adding 3 of something plus 1 of the same thing. And when I do that, I can simply add across for the numerators 3 plus 1. 3 of something plus 1 of something is going to be 4 of that something, and that something is thirds. So now I can rewrite my total expression as, instead of 1 1/3, I can write 4/3. And again, I still have my plus 3/4 and plus 4/5. All right, that's better. I now have my first term written as a fraction and proper fraction, and I would like to add these 3 terms together. But I cannot add them at this point quite yet because they aren't expressing the same thing. I have thirds, fourths, and fifths. So these are different things, and I can't add the numerators together yet. What I need is to find a common denominator of 3, 4, and 5. So of those denominators, what I'm really looking for is a common multiple. It doesn't have to be the least common multiple. And because of that, one way I can do that is to simply multiply them all together. So I can multiply 3 times 4 times 5, and that will give me, see, 3 times 4 is 12. I still have my 5. And 12 times 5 is 60. So now that's what I would like to do. I would like to express each of these fractions not in terms of thirds, fourths, and fifths, but as 60ths. So I want to have some number of 60ths plus some other number of 60ths plus, for my third fraction, some number of 60ths. But my question is, Now, how do I figure out what these are? Let's take a look at them one at a time. So 4/3, I want that to do something to it so that I get 60ths. And really what my approach is going to be that I'm going to multiply 4/3 by the number 1, because multiplying by 1 doesn't change my number, but a special formulation of 1 so that I get a fraction with a 60 in the denominator. So really, if I'm going to multiply, I have to multiply 3 by something to get 60th. So 3 times 20 equals 60. I could take 60 divided by 3 to find the 20. So that's what I want to do. I want to multiply this fraction by the fraction 20 over 20, because that's just 1. And so I multiply 3 times 20 equals 60, but on the numerator, I have 4 times 20 is 80. That's what I need. Let's do that again for the second fraction. 3/4 times some expression of 1, and I'm going to get 60 for a denominator. Well, in a similar manner, I take a look at this 4 and 60, and 4 times what number equals 60? Well, 60 divided by 4 is 15. So that is what I need in the denominator here. And to make this factor 1, I need 15 in the numerator. 15/15 is 1. I'm not changing 3/4. I'm just expressing it differently. 4 times 15 is 60, and then the numerator, 3 times 15 is 45. So I'm going to write that up in my expression for the total. And lastly, I have the fraction 4/5. 4/5 times 1 is going to equal some number of 60ths. But which value of 1 am I going to use? 5 times something equals 60. Well, 60 divided by 5 is 12. So that's what I need. 5 times 12 is 60. Yep, that checks out. So I'm going to put a 12 here. And if I want to multiply 4/5 by the number 1, keep it unchanged, I need a 12 in the numerator. So 5 times 12 is 60 for the denominator. 4 times 12 is 48 for the numerator. So that's what I have here, 48. Now I have a sum of 3 fractions, but they're all of the same thing. They're all 60ths. So I can add them, and I get 60 on the bottom. What do I get on the top? 80 plus 45 is 125. And then if I add 48 to that, I'm going to get 173. 173 60ths. That is my sum. Well, now 173 60ths is an improper fraction because the numerator is greater than the denominator. So let's go one more step and determine what we would have if we were to write this as a mixed number. So to do that, I'll employ long division to see how many times 60 goes into 173. So 2 times 60 would be 120, and 3 times 60 would be 180. That's too many. So 2 times 60 is what I want. 2 times 60 is 120. And I find out by subtracting that my remainder is 53. So I have 53 60ths. So that is what my total is going to be. 2 and 53 60ths. And that's pounds. So my answer to the question of how many pounds did Sarah buy during the first 3 weeks of summer is 2 and 53 sixtieths pounds.